we're going to look for the x-coordinate. Now this is really important that you read the directions because you're looking for only the x-coordinate. So probably what we're going to do is we're going to go ahead and eliminate the y. I would line them up. That's what I would do on this one. So I would add the 2y over to both sides. So it would end up to be 5x plus 2y equals a negative 8. So that just came from this way, right? And then this guy right here, I would maybe subtract the 5x. And so now I have negative 5x minus 2y equals negative 4, because this is now gone, right? So when I do that, you can see after I've lined them up that when I add these together, you can see they both zero out. So when they both zero out, you get 0 equals negative 12. Well, this is false. So when the variables are gone and then you get a false statement, the answer is no solution. It's totally up to you which thing that you're going to use, but you can see here how the y or the x is alone. So you can use substitution on this one. So everywhere you see an x, you can substitute that guy in where you see the x. So you have negative 3y minus 5 times negative 3 minus 3y equals negative 9. The thing here that you have to remember is that you're taking a negative 5 all the way through. And then you're going to just solve for the y because you have like terms right there. Now, the key here is this is y, but we're asking for x. So we're going to go ahead and substitute that back up into here. So we have x is what happens when you have negative 3 minus 3 times our y, which is negative 2. So negative 3 plus 6, which is 3. So our answer there is 3. So this they're asking identify the vertex of each and then sketch the graph. So you can see that this is in vertex form. So what we're going to do is we're going to say, okay, first of all, we know that this is positive, so it's going up. Okay, we also know that the vertex, because there's nothing with the, there's nothing with the x value here, so that's going to be 0. And then I'm going to use a different color. And then this guy is plus 5. Oh, shucks, I didn't mean to do it that way. This guy is plus 5 or minus 5, so we're going to say that this guy is negative 5. So this is the vertex. So let's see who has the vertex. Let's do that in a different color. So the vertex, this guy has the right vertex, this guy has the right vertex, 0, negative 5, 0. Actually, they all have the right vertex. So far, we have the right vertex on all of them. We know that it's going up, so this guy can't work out. This guy can't work out. So we only have 2 that can work out. So the next thing that we're going to use is this 3. So the 3 means that, like, for the parent function, it would go up 3 over 1 just for the parent function. Because normally it would only be over 1, up 1, but we're going to stretch 3. So that means this is going to go up 3. So when we go over 1, it's going to be going up 3. It's 3 times as high. So if I were to be at the vertex, which, look at this vertex, is that So if I was going to be at this vertex, which is right there, sorry, and I went over 1, I would want to go up 3. So if I went over 1, where would that be? That would be at 1, and then I went up 3, that would be at -2. So my nether point needs to be at 1, -2, and that's a pretty good area right there. But if I went here and I went over 1, you see how 1 is only giving you right there? That's not going to be a good stretch. You can see how that one's more compressed, whereas this one's more stretched. So just by looking stretch or compressed, you can tell that it had to be B. Now, if you wanted to, could you just put a value in, like make a table and put like a 2 in and see what came out, put a 1 in or put a 2 in? You could do this. You could make just a table. Okay, so that's up to you. Okay, so axis of symmetry. This is the x value of the vertex. That's what the axis of symmetry is. So that's what the axis of symmetry is, and we're going to continue that in 1 second.